Hey guys, welcome back for another instructional tip. I want to talk to you guys today about speed control and the reasons why it's difficult to talk about it and how you can start taking control of your speed. What we're going to be talking about first is why is it tough to discuss? You know, when we're trying to describe speed, it's always subjective, right? You're using terms like soft, medium, and hard, and your soft, medium, and hard are going to feel a lot different to you than what they are to somebody else. So today what we're going to be able to do is quantify speed. We're going to actually use this ruler of a pool table that we have. We have 8 units called diamond segments, and we're going to be able to use those 8 diamond segments to be able to start calibrating and talking about speed with quantification, actually applying some sort of a measurement that you can use when discussing with your team and when you're just trying to learn stuff through the videos that we use, because I'm going to be using that same type of language. And then I'll also show you a couple of different ways where you can not only practice your speed control, but also how to identify speed trade-offs. Using fractional ball aiming, which was covered in a different video, you'll actually be able to identify how much energy is going to stay with the cue ball, how much energy is going to stay with the object ball. So the first thing that we're going to talk about is this setup here. What I have is a game that I've invented called golf. And golf is just like how it sounds. You're going to tee off, and how you tee off is always from this first diamond line. And you're going to count your number of strokes. So for holes number 1, 2, 3, and 4, we do not need to touch a rail. For holes number 5, 6, 7, and 8, you have to bounce it off of one rail. And then for hole number 9, you're going to bounce it off that rail, bring it all the way down, bounce it off this rail, and back up to number 9. How you know that it's in the hole is when you're looking straight across from whatever that ball is, the plane is interrupted by the cue ball. So if the cue ball comes across this one ball and the edge crosses the one like so, until the edge doesn't cross the one anymore, at the time that it's crossing in a perpendicular line, that's when it's in. If it's not in, you keep shooting. It's still a matter of accuracy. So if you were to touch one of these balls, or if you disturb the long rail, then that would be +1 stroke, like a sand trap or a water hazard. So I'll give you an example here of what this might look like. We're going to go for hole number 3. When you're playing amongst yourselves, do them in order. Hole number 1, hole number 2, and everybody they're playing with would shoot for that hole, and then you record what the strokes are. Par on this course is 18, so 2 per hole. So if I was to roll to hole number 3, I'm going to try to get a hole in one, of course, and I overrolled just a little bit. I'm actually okay with that happening, so you can see what this is about. So what I just did was I rolled the cue ball 1, 2, 3, 4, 5, 6 diamonds on a shot that required 5. That was actually 20% too hard. It seems like I was just a little bit too far, but the reality is that's 20%. That's just math, right? So I'm going to try and just roll up here. And now I'm in. I'm within the plane of that ball. It doesn't have to be perfectly lined up, just so that the edge crosses the edge. So that was par. I shot 2 strokes on that hole, and that's what that would look like. There's no requirement to touch a rail, but there's also no punishment. So if I was going for hole number 4 and I touched that rail, there's no punishment. You can hit too many short rails, you just can't hit too few. For holes number 5, 6, 7, and 8, we're going to bounce off this rail. So let's say I'm going for hole number 6 here. I have to at least touch that rail down there. So we roll the ball down and have it try to come back up. And if it doesn't go in, I'm just a hair short, we'll just do a little putt, and then we're in, right? So, lastly, if we're talking about hole number 9, we're going to go down, back, and up again. Instead of me going for hole number 9 the correct way, let me show you what happens if it's incorrect first. So if I try to roll that ball down and back, I don't just get to roll to here. what I'd actually have to do, because the minimum number is 2 rails, I have to actually bounce it off that other rail to satisfy the minimum. We said that we're going to end up doing 2 rails, 1, 2, and since my first one I only did 1, I still have to satisfy the minimum by hitting this rail. So this was also 2 strokes. I got par on 9 by doing it the incorrect way. If I wanted to do it the correct way, of course, I'd go 1, 2, and then back up here to hole number 9, right? So that's the way that we play golf. By doing golf, you'll be able to keep your scores. Again, par is 18. My personal best score is 13. The best score I've seen from another student is 13. I've never seen anybody get less than 13. So practice it, and if you can get enough hole-in-ones on this drill where you can get it down to 12, then you will, of course, be the new winner. Let's take a look now and talk about speed trade-offs. When we're talking about the fractions of hits, what we can actually do is identify how much energy is going to stay with the cue ball and how much is going to stay with the object ball. In a previous lesson, what we talked about was some basic fractions. So here, what we have is a 1 diamond, a full shot, where the object ball is 1 diamond away from the pocket, the cue ball is 1 diamond away from the object ball. We're going to assume Pythagoras didn't exist. We're just going to say that that's a solid 1 diamond, because the reality is golf taught us what 1 diamond is. Do we need to be any more precise than that? I mean, if that's 1.41 diamond length, or whatever that may be, if we're taking this class on speed control, we don't care that much, right? So we're just going to call it 1 diamond to make the math simple. On a full ball hit, the fraction is 1 over 1. That's what makes a whole, right? A half would be 1 over 2, a quarter would be 1 over 4, and so just quick math review, the top number of a fraction is the numerator, the bottom number of the fraction is the denominator. The formula goes like this. We take the after collision distance, that's however far away the object ball is from the pocket. That after collision distance is going to get multiplied by the denominator. So in a full ball hit, the denominator is 1. I have 1 diamond times 1 equals 1. Then we're going to add in the before collision distance, which is 1. The reason why we do that separate is because the cue ball doesn't know it's a full ball hit until it actually strikes the object ball. After collision is what we really care about, and then we can just add in whatever's left over. Therefore, after collision is 1 times the denominator of 1 over 1 is 1. Therefore, after collision is 1 plus before collision is 1. We have a total of 2 diamonds worth of energy is necessary just to make that 8 ball go kerplunk. If we come over here to a half ball hit, how much energy do we need? Well, the after collision is still 1 diamond. That's the distance. And now the denominator is 2. 1 over 2. Denominator is 2. So we're going to multiply 2 times 1 equals 2 plus the before collision. 3. 3 diamonds worth of energy. Well, what does that look like? 3 diamonds worth of energy is the distance, the speed necessary just to roll that 3 ball, or that object ball up to the rail, right? That's 3 diamonds. So, does it seem feasible that the 8 ball would go in with that tiny little bit of speed? Well, let's find out. Sure enough, that's all we needed, 3 diamonds. Notice here that the cue ball and the 8 ball had the same amount of energy. This is what we call equal separation. The 8 ball traveled forward 1 diamond. The cue ball traveled forward 1 diamond. This is what that looked like if we were to do a countdown. We started with 3. We went to 2. There's the before collision. The object ball stole 1. Now we have 1 left, and the cue ball takes that 1 and comes over here. This is very valuable stuff for us when we're trying to do things like play defenses. If we were to play a half ball defense, all we have to do is focus on equal separation because it's half ball. The object ball takes half, the cue ball takes half. So here, I have 1 diamond to the 4 ball. I have a half ball hit, and the cue ball is 1 diamond back from that. Therefore, 1 diamond here times the denominator, which is 2, equals 2, plus the 1 from here to here. 3 diamonds worth of energy with a half ball hit. And I hit that one a little hard, but you can see it's a pretty good half ball hit. It's still enough, actually they can't see it, so it was still a good defense, even though it was a touch hard. Alright, moving along, let's talk about a quarter ball hit. 45-degree cut shot would be a quarter ball hit. If we were to send this cue ball with just enough speed to make the 8 ball fall in, how do we identify this? Again, after collision, that 1 hasn't changed, times the denominator, quarter ball, so it's going to be 1 times 4 equals 4, plus the before collision, 5 total diamonds. So as you can see, each time we get thinner and thinner on the shot, the further the cue ball is going to travel after collision, because the object ball is not going to take as much. It also requires more energy because the object ball doesn't take as much. Here, the object ball only gets a quarter of the total energy that we started off with. So if we start the cue ball with 5, comes here, has 4 left. The object ball takes 1. Now we still have 3. Cue ball is going to go 2, and then 1, and then 0. Cue ball goes back to the middle of the table with 5 diamonds worth of energy. So I'm going to give you just a brief second to kind of think about what would we do here. This is a quarter ball cut shot, the old spot shot. First of all, if you think that you're going to scratch on this shot, consider what the cue ball is doing. Just as a brief reminder, when you see one of these, yes, the tangent line is a scratch, but that's only if the cue ball is sliding. If it's rolling, it will go forward to the tangent line. You'll be safe. If it has draw, it will go backwards to the tangent line. You'll be safe. Here, I would encourage you to hit high on the cue ball, because that's what the cue ball wants to do. It's a lot easier to make it roll forward than to hit hard with a draw. It's going to slide down that tangent line before the spin grabs anyways. But that's for a different lesson. So we're going to hit this ball with a rolling cue ball. We just want to make the 8 ball fall in. Where again, Pythagoras doesn't exist. There's 2 diamonds and it's a quarter ball hit. 2 times the quarter ball hit denominator, 4, equals 8, plus 2 diamonds, 10. Where's the cue ball going to go if we just do this with pocket speed? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Comes right back to the middle of the table. Useful stuff to know. And beyond the other versions of how we can use speed control information, such as what's the pocket speed actually? We always talk about pocket speed, but what is it actually? So today what you've done is you've learned that. You've also identified where's the cue ball going to go if I hit pocket speed. How useful would this be to know I can't hold it for this 9 ball? With a quarter ball cut shot, if I try to pocket this 8 ball in that with just pocket speed, it's going to be quarter ball times 1, 1 times 4, right? It's a denominator is 4, so it's a quarter ball, 4 times 1, plus 1 is 5. 5, 4, 3, 2, 1, 0. If we end up leaving ourselves this shot, it's because we just didn't consider what we were doing with our speed control. You got to do something different. It's not that you can't hold it, but you'd have to use spin or do something different. Maybe you want to bank it. You have other choices. But just knowing where's the cue ball going to go allows you to make those decisions. So I hope that this was helpful to you. Think about all the different ways that you can use the fractional ball aiming for speed control and speed trade-offs, and definitely practice some of those half ball hits that's going to allow you to do things such as you don't have to bank the shot. You can make your opponent bank the shot simply by, if you have a shot such as this, play a half ball hit. Cue ball is going to come up here and over here. The object ball comes over here. Let them bank the shot because you did an equal separation half ball defense. I hope this helps you. I hope, if nothing else, you practice golf and you have some good fun with it. And so the next time that I start working with you in person, because you're going to sign up for the Ultimate Dragon, where you get a half-hour lesson included every single month as part of that package, then we have a common language that we can talk about because you've already done your homework and practiced golf. Talk to you soon. Train better, do better, and shop better. And thank you for subscribing. I really appreciate you. DragonBilliardsInstruction.com.